so correct me if I'm wrong here. 9-1, numbers 1 and 4.
Mm-hmm.
Okay. So we're gonna graph. We're being asked to graph the parametric curve. X is equal to t squared plus t.
And y is equal to t squared minus t.
Thank you. T squared minus t.
Yes, sir.
And we want to get a basic idea. We could use our calculators for this. Go into parametric mode and plug in.
Do you want the range that it gives?
Oh yeah, if it gives a range, sure.
It says -2 is less than equal to t, which is less than equal to 2.
2. All right. So they just want it right there.
Yes, sir. Best I can tell from the book.
Okay. So let's just plug in some values from t, plot some points, try and get some idea of what's happening here. So I'm gonna make a t table, remembering that I'm actually getting points out, right? And the points I'm going to get are the x and the y that are determined from these two equations. So start with -2. Plug in -2 here. So we go -2 into this. We should get 4, then plus -2. So that should be 2. And then what about this next one? We've got -2 squared is 4 minus -2. So we're going to get 6 there. So 2, 6. Let's do -1. So we've got -1 squared, 1, then -1 is 0. And then -1 squared minus -1, so we should get just 1. No, 2. Sorry, 2. 2, 2. All right, then we plug in 0. This one I can do. This one I can do. 0, 0. Okay, plug in 1. We get 2, 0.
I thought it was 3, 2. Oh, no, you're right.
2. Yeah. 2 is 4, 2, that's 6. And then 4 minus 2 is 2. All right, so now we'll just plot these points. And when we plug in -2, we're at 2, 6, which is right here. And then when we go to -1, we're at 0, 2, right here. Now, we want to remember that as t changes from -1 to from -2 to -1, we're going from this point to this point, and it should be a curve. These are both parabolas, so it's not a straight line. So we have some sort of curved shape connecting these, okay? If we did more values of t, we would get a better idea. But I'm just going to imagine that these are somehow connected with some sort of curve. And then the next point is 0, 0, which is here. Now, again, I know from here to here is not a straight line, so it's got to be a curve. And most likely it's going to do something like that. But again, I need more points to be able to get that much detail. At 1, we're at 2, 0, so that puts us here. And we've got to curve our way over there. So again, I'm going to kind of assume that it must do something like this. And then the next point is 6, 2. So 2, 3, 4, 5, 6. 6, 2 is here. So it kind of curves its way over here. Something like that.
Yeah, that's good.
Looks good. All right, that's it. Number 4. Same sort of thing where we have to plug in points. Nice. This really I gave more as a homework assignment because I wanted you to maybe use your calculators. But if we're going to do it by hand, this is what we'd have to do. So number 4 is e to the -t.
Plus t.
So x is e to the -t plus t, and then
Y is e to the t minus t.
And then restriction,
-2 to 2 again.
-2 to 2.
And it is, less than equals.
All right. More table stuff here. Now, when we do this table, we're going to get exact answers, and then we're going to need to approximate them with decimals. So let me do our t, here's our x and our y. So if I go t is negative 2, I should get e squared, that's e to the negative 2, and then plug in negative 2 here, minus 2. That's our x coordinate. Our y coordinate will be e to the negative 2, and then minus, so plus 2. And let me go ahead and get those as decimals, and I actually have it right here. It's 5.39, and the other one is 2.14. Then we plug in negative 1, and I think I'll save us time here. I'm just going to give you what these decimals are. Is that all right?
Yeah. Sure.
1.72, 1.37, and then at 0, we should be at 1.1. At 1, we should be at 1.37 and 1.72. And then the last one is actually the first one flipped over. You'll see kind of this weird symmetry that we have. It's like when you plug in the negative 2, you get this, but when you plug in positive 2, it's the x and y's got flipped. Interesting. All right, so try and graph this here. At negative 2, I'm at 5.39, 2.14. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5.39. 5. Here's 6. So here, up 2.14, somewhere around here. Then we need to get to 1.72, about right here, up 1.37, about right there. And then we need to get to 1.1, which is right here. And then 1.372 to 1.72 is right here, roughly. That's actually not good at all. I went too high up. It's actually about right there. And then 2.14 to 5.39, somewhere around there. So I need to connect these dots. And again, they're not straight lines. And if we did it on our calculator, we'd see it almost looks like a cusp, like sideways.
Yeah.
Goes like that. Roughly, that's it. The idea is that you can draw some weird stuff, right? And that's it. That's it for the first section. We just want to be able to draw some things. Now, 9.2. Wow, I give a lot of problems in 9.2. Number 3. I don't have the questions here, so.
Here, would you like to just see my book?
No, I like it when you read it to me. That way you can look at it and I can. So, we are now in 9.2,
Yes, sir.
right? Okay. I'm not going to do a different video for it. I'm just going to keep it all together.
I mean, it's not like it's a lot of problems.
Yeah. I might stop after 9.2
Sure.
and then switch.
We'll be forever commemorated and
So you want problem 3?
Yeah. So number 3, 9.2.
Yeah. X is equal to 1 plus 4t
Okay.
minus t squared.
Okay.
Y is equal to 2 minus t cubed. And the only parameter I see is that t is equal to 1.
Okay, so the instructions say probably find the equation of the tangent line
the curve
at this point. So this draws some curve in two-dimensional space. Let me get this real quick. Hello?
And we're calling in reference to your current credit card account. There's no problem with your
Just crap.
It is urgent, however, that you contact us concerning your eligibility.
This is one of those ones where you press whatever to get off their list.
Little as 6.9%. Your eligibility.
So
And now we know what happens when the video cuts off.
Press 1 now
I won't edit this.
to speak with a live operator and lower your interest rates. Or press 2 to
Yeah, you
discontinue
have to
further
change it to
notices.
the, and then you just use.
Type it in like that?
I've been getting so many of those things.
But don't we have to make one of them block?
Okay, so we have to find dy dx. And the formula for this is dy dt over dx dt. This is the slope of your tangent line. And dy dt is just the derivative of this with respect to t, which is negative 3t squared. And the derivative of x with respect to t, which is just derivative of this, which is 4 minus 2t. So all I need to know in order to figure out the slope of the tangent line is the t value, which corresponds to the point on the curve, where I'm actually trying to find this tangent. So they give us t as 1, so just plug 1 in there. So at t equals 1, you have that dy dx is equal to negative 3 times 1 squared over 4 minus 2 times 1, negative 3 over 2, negative 3 halves. Yeah, that's pretty easy. Is that all they wanted? Oh, did they want the equation of the line?
Yes.
Oh, they wanted the equation of the line, not just slope of the line. So if they want the equation of the line, that's just the slope. Now we need to do
Y1.
your formula, y1 minus, now do we know a point? Do we know the point on this graph though? Because if we're going to use this formula, y minus y1 equals m times x minus x1, we need an x1, y1.
Well, we have a t.
That's right. So that t,
And we know what that point gives us, though.
that t here gives us, this is the slope of the tangent line at this, right?
Right.
But what's the point that we're at?
We could
That
just
one.
use rise and run to kind of reverse it, or we could plug in 1 for the equation.
Yeah, just plug that 1 in here and won't that be where you are,
Yeah.
right? Okay, so the point that we have here, x1, y1, is just what? So plug 1 into this, you get 4, 5, take away 1, so you get 4.
Yeah.
And then here, plug in 1, you just get 2. 1, 2 minus 1. 4, 1? So that's our point, and then we already knew that our slope was negative 3 halves. So going to that formula here, y minus 1 equals negative 3 halves times x minus 4. That is the equation of this line. You could solve that for y, but I don't care if you do.
It's pretty simple.
Just make it a negative.
All right, let's look at number 5.
All right, x is t cosine t.
This is 5, right? 5.
Yes.
Okay. T cosine t,
Y is t sine t.
t sine t,
Evaluated at pi.
pi. Same thing. Find the equation of the tangent line. So we first need the derivative, which will give us a slope. So to get the derivative, dx dt, or sorry, dx dy dx is equal to dy dt over dx dt, which is, now we have to take derivative of the y first, product rule,
Yeah.
right? So sine t plus t cosine t is the derivative of the top. Y'all agree?
Yeah.
Derivative of the bottom is cosine t minus t sine t. So we had to do 2 product rules there. Now at pi, we're just going to plug pi into this. So at pi, you get that dy dx is sine of pi, what's sine of pi? 0, plus pi times what's cosine of pi? Negative 1, right? Over cosine of pi, which is negative 1, minus pi times 0. So it looks like you're going to get negative pi on top and negative 1 on the bottom.
So then we just divide that out by pi.
You You just have pi. So the slope is pi.
I feel like we should do that problem on pi day.
Now we need the equation of the tangent line.
So just plug it in.
We need to plug pi into this to get the point. Right, so what is the point that corresponds to
That'd
t
be
equals pi?
negative yeah, negative
So-
pi and
So
zero.
my x1, y1
Yeah.
is going to be
Negative pi
pi times negative 1, so negative pi
And zero?
and 0.
and 0. So that's where I am.
Okay.
And now the formula, y minus y1 equals m times x minus x1. Yeah. So y minus 0 equals m, which is pi, times x plus pi, because you're minus minus. And this one, I think I can clean this one up without doing too much work. So y equals pi x plus pi squared. So this is a line that has a slope of pi that has a y-intercept of pi squared.
That's what blows my mind. The slope of pi.
A slope of pi and a y-intercept of pi squared.
So the slope 3.14 over 1. Something like
Yeah.
that. Slope of pi.
All right. These are pretty straightforward, right?
Yeah.
I mean, this is what I'm looking for on the final. I'm not, I want to keep it just, you need to know how to do this, that's all.
You're not going to crank it up
Yeah.
a lot more than that?
Let's see how these go.
With 13.
See if 13 gets any worse. So
So just
13, what is it asking for?
find the points on the curve where the tangent is horizontal or vertical. If you have a graphing device, graph the curve to check your work.
Okay, so we're just going to try and see where this thing is horizontal or vertical. Number 13.
X is equal to t cubed.
Minus 3t,
Mm-hmm.
and then y is t squared minus 3.
Okay.
No parameter given.
No, right?
Yep, so they don't give you anything, so they're wanting to know when is the slope of the tangent line horizontal and vertical.
What's this or?
Or, yeah, we'll look at them both.
Okay.
Yeah. So let's first figure out what dy dx is. And to do that, just, we've done this twice now, so 2t over 3t squared minus 3. The derivative of the y function over the derivative of the x function. Okay, so let's look at horizontal. Where is the tangent line horizontal? Well, that's going to happen when this is 0. Right? When this is 0 is when you have a flat tangent line. So when you look at a fraction being equal to 0,
When t is 0.
is only when the top is 0.
When
so-
t is 0.
2t equals 0, which means t is 0. So it appears that the only time that it happens is at t equals 0. Now they actually probably want the point.
It does mention that.
Yeah, so that's when it happens, right? At t equals 0, but what's the actual point that corresponds to that? So where are you on the curve when you get that tangent?
0,
0,
negative 3.
negative 3. So you're just plugging that t equals 0 in there. So if I were to graph this on my graphing calculator and look at the point 0, 0, negative 3, you should have a flat horizontal, a horizontal tangent line is what you should have there. The computer actually, what I'm looking at here actually graphed it and it looked like this. Oh, that's supposed to be your x-axis. Wow, I missed. See, yeah, it looks something like this. Wow. Wow, that's terrible. But that's supposed to be the bottom. Hold on. So right here is the point 0, negative 3, and you can see it does have a flat tangent line there. Okay, so we look at where it's vertical. Where is it vertical? Well, it'll be vertical whenever this is undefined, which means you get division by 0. So we need to set the denominator equal to 0, which means 3t squared is 3, which means t squared is 1.
Square root
So t is
1 and
plus or minus 1. All right, so let's look at when t is 1. When t is 1, that corresponds to the point negative 2, negative 2. And when t is negative 1, it corresponds to the point to negative 2. And that would have been these 2 points right there, vertical tangents. Okay? Actually, kind of enjoy this a little more when there's people in here with me.
Us too.
You're not just talking to yourself like a crazy person?
It's more enjoyable in real life. Like your videos are amazing, but they can get just as lonely when you're just like in your
On the other side, yeah.
alone, dog looking at you like crazy.
All right. 15, is that where we are?
Sure. Yep.
15.
Alright, so x is 2 cosine theta, y is sine 2 theta.
And they're, same question?
Yes.
All right, so on this one, they're using the parameter of theta instead of t.
That's totally fine.
It's like a dummy variable. You know, like we use x and y normally, but there's nothing that says we couldn't use 2 other letters. So we're going to use theta.
Differentiate in terms of theta.
That's right. Yeah. So dy dx is actually, if you follow the formula, it's dy d theta over dx d theta because we don't have t. But it's still just derivatives. So chain rule on the dy.
1/2 sine 2 theta. No,
You're
that's the opposite.
yeah, you're integrating.
Sorry.
No, that's all right. 2 cosine 2 theta.
Yeah.
And then
Backwards for so long.
the other one, I know, right? 2 sine theta is the negative 2 sine theta is the derivative of the other one. We can cancel the 2's. So we have cosine 2 theta over negative sine theta. That's our derivative. And we want to know when our tangent lines are vertical and horizontal. Okay, so let's do the horizontal first. So we set the numerator equal to 0. Numerator to 0, cosine 2 theta is 0. And we're going to get general solutions here. Now, be careful because that's 2 theta in there. So here's how we do this. First of all, where is cosine? 0. That happens here and here. Okay, so what we need is that the argument of this trig function, which is 2 theta, we need that 2 theta to be equal to pi over 2 plus pi n. Now we're getting that general solution. So pi over 2 plus pi n, we did that in class. I screwed it up in class because I put pi over 2 here. But you start out at pi over 2 and then you add pi's to get around this thing. But it's 2 theta is equal to that, not theta. And that's important because now you have to divide both sides by 2. So theta must be pi over 4 plus pi over 2 n. So I'm dividing each of those by 2. Now, that's fine. You can leave it like that. But what I like to do when I'm getting general solutions, if I'm going to start listing them out, is I like to get a common denominator here. So I multiply the top and bottom of this by 2, and I'll have a 4 down here, right? And when I put them together, here's what I'll have. Not 3 pi, careful. It'll be actually this. You cannot combine those two numerators together, right? Because this one had an n. So why do that? The reason why is this. If I start asking you for these, like give me a couple of these, right? If you look at this one right here and you plug in 0, you're going to get pi over 4. That's simple. But if you plug in 1, now you're going to have to do pi over 2 plus pi over 4, which means you'll have to get common denominator. If I plug in 2 here, you're going to have to do like pi plus pi over 4, common denominator, which I'm not saying you can't do, but look at how easy it is here. If you plug in 0, you just get pi over 4. If you plug in 1, 3 pi over 4. If you plug in 2, 5 pi over 4. If you plug in 3, right? You see how much faster that is? Okay, but does it ask for us to list them or no? It does not, right?
No.
It does not. Okay.
Well, it does say find the points on the curve where the, yeah, so just says find the points, that's it.
Okay, so we'll do the points. Let's actually start plugging in values into this. Let's start with our first solution, which would be pi over 4, right? So I'll make my list. This is pi over 4. Then we have 3 pi over 4. Next one's 5 pi over 4. Understand? 7 pi over 4. 9 pi over 4. Dot, 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 dot. It's just all the odd powers, or all the odd pi over 4s. So let's plug pi over 4 into what?
Thetas?
Yes, but where?
At the original.
The original, right? Because I'm trying to find the points. So what is cosine of pi over 4? Root 2 over 2 times 2 is root 2. So corresponding to this one, I get root 2 for the x. What about for the y? So plug pi over 4 in here.
You get
So
pi over
you get pi over 2.
which is 1.
Sine of pi over 2 is 1. Good. So that. Now let's plug in 3 pi over 4.
Negative radical 2 for cos.
Yeah, so we're 3 pi over 4 is right here. Cosine of that is negative root 2 over 2 times 2. You get negative root 2. And then what about for the sine? So you have to plug in, you have to take this and double it first, right? 6 pi over 4, which is 3 pi over 2.
1 again. Negative.
Sine of 3, yeah, you're at negative 1. Now plug in 5 pi over 4.
Root 2, no, negative.
Negative root 2. So this is negative root 2, and then 5. This is, when we double that, it's going to be 5 pi over 2. So where's 5 pi over 2?
1 again.
You're up.
Negative 1.
No. Here, look, here we go. Here's, we're at 5 pi over 2, right?
Which is,
This is pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2.
which is 1.
I thought you said negative 1.
No, I corrected
Oh,
myself.
okay, I'm sorry. I didn't hear you correct yourself.
Sorry, I said
Okay.
negative 1 and then I was like, oh, no,
Yeah,
1 again.
so it's 1, yeah.
Yep.
Okay.
One full swing.
So it does not look like we have started repeating ourselves yet. We had root 2, 1, negative root 2, negative 1, negative root 2, positive 1. I bet you the next one's going to be
Radical 2, negative 1.
negative 1. We'll see. Let's see. So what about this one? 7 pi over 4.
This is in quadrant 4, so we should have a positive root 2 and a negative.
Positive root 2.
Well, double that means 14 pi over 4. 2 goes in there and becomes
So
7 pi over 2, which is
7 pi over 2.
in negative 1.
1, 2, 3, 4, 5, 6, 7. So we're at negative 1.
Okay, so
And
wait, that's a repeat. No, it's not.
it's not, but I bet you the next one does.
That'll be the
Yeah.
ticket.
The next one's going to probably repeat. So 9 pi over 4, plug it in, it repeats. So those are the 4 places.
That's the first
Right.
pair again, right?
Yeah.
Root 2.
Yeah. So the book actually lists it like this. Here are your answers. Those are the points.
They're not wrong.
Every combination that you can come up with there. Right?
Not wrong.
That's all 4 possibilities.
What's funny is when you have all of that work,
Mhm.
it's brilliant and beautiful. But if you just like had a question and answer, it would look like simplified and what the hell are you talking about?
Yeah.
You're crazy. But when you show it all along the way, sure, why not?
Okay, that's when it was horizontal. When is it vertical?
Well, it's basically going to be everywhere that you hit a solid pi. So
It's pi in.
So all we're doing is setting the bottom to 0, and the negative doesn't matter. So sine theta is 0,
at pi and well, 0 pi, pi, 2 pi.
0 in here.
Yeah.
So how about we just say that our theta has to be 2 pi n, or not 2 pi n, pi n.
Pi in.
Yeah,
Pi n.
that's what I put.
You could go pi n. You could say pi plus pi n. You could do 0 plus pi n. Doesn't matter. It's the same thing.
Because if you're at 0, then you just add pi.
All right. So that's it. And now
plus or minus radical 2 plus or minus 1 as your horizontals? And then
Yes.
Walk by it and you walk.
Well, no, because we have to plug these in, remember? We have to
Oh,
plug them
yeah,
in.
yeah,
So let's list out a few of these. We've got 0, we've got pi, we've got 2 pi, 3 pi.
This
4
is too
pi.
hard. This is labor intensive.
Yes, it is. So plug in 0. Cosine of 0 is 1. So we get 2, 0, right? 2, 0. That corresponds to this one. Plug in pi. Cosine of pi is negative 1. So you'll get negative 2. And then sine of 2 pi is 0. We're always going to get zeros out the y coordinate.
Your answer, your general solution would be plus or minus.
Yeah, plus or minus 2, 0. We could just verify by doing one more, but that's good enough.
Yeah, 0 is 0.
Yeah. Yeah, because these are the same angles, right? Basically the same thing. All right, that's it. That's number 15. Number 19.
Number 29.
Oh, 29? Okay. Yeah, I just read that wrong.
Gotcha. So they want you to find the area enclosed by the x-axis and the curve. I'll wait for you.
Yeah, go ahead. What is it?
X is equal to 1 plus e to the t, and y is equal to t minus t squared.
That's all they give you.
That's all she gives.
Okay, now, so we did not do anything like this in class.
Really? I thought we did.
I mean, we did find areas.
With some e to the t and some other just parabolic function, and then it was like some coefficient.
Back before, not with parametric though. Yeah.
That's what I'm saying.
So without even looking at this thing's graph, let me point something out. Your x coordinate is always positive because e to the t is always positive plus 1. That's always positive. So I know that when I graph this, if I graphed it, it's always over here in the first or fourth quadrant. Now, here, this is a parabola. So my y coordinate, I would like to know the area between this curve and the x-axis. I would like to know when this y coordinate actually is 0, because that would give me x-intercepts. So let me set y equal to 0, and that would give me t minus t squared equals 0, which means t 1 minus t equals 0. So I should get t is 0 and t is 1. Understand? Just solving those equations. Yeah? So I have two points, not points. Yeah, 2 points, but two moments in time. If we're going to look at t as being time, we have like 2 moments in time where our y coordinate is 0. And I want to put those on my graph. So if t is 0, hold on a second, what is this?
Shouldn't we set x to 0 too? No.
Sorry about that. Okay, t is 0. So what I'm going to do is actually find these points. At t is 0, I just plug 0 into both of those. Here I'm going to get 2, right? E to the 0 is 1, 1 plus 1 is 2. So I have the point 2, 0, right?
Yeah. Yes.
Because I know when I plug in 0 here, I'm going to get 0. So 2, 0, 1, 2, 0. I know I have a point there. And then when I plug in 1, I'm actually at e to the first power. So e is about 2.718. Plus 1 is about 3.718. So here's 1, here's 2, here's 3, here's 4. So 3.718, I'm about right there, right? And then I could check real quick, because this graph, the y coordinate is parabolic, right? So I should have some sort of parabolic shape here. Yeah, if I go to 3, I could check to see if it's above or below. So let me just quickly ask myself, let's take a point in time between these 2 points.
3.
Point in time. So like, how about t is a half? Yeah, you can't get the x-coordinate confused with the point in time. We know that at t equals 0, we're here. We know that at t equals 1, we're here. The question is, do we go up or down? So if I pick a time in between, like 1/2, and plug it in, what would I get? I don't care too much about this. I care more about this. So what happens if I plug 1/2 right in here?
You get a half minus a
Half minus a fourth,
negative fourth.
positive fourth. A half minus a fourth is positive fourth. So it's a positive y. So I know that between here, I'm like this, right? Understand?
I hear it in my mind correct, and I gave you the wrong fraction.
Yeah. But the thing is, it's not a parabola, a true parabola, because the x-coordinate is this. And I know this can actually never be less than 1. So I know it's got to have some sort of asymptote like this. So it's going to go like this. And then on this side, it's just going to dive down and do something like that. Something. I can't guarantee how that looks, but good enough. We want this area. Is that close? Somewhat?
Close enough.
So we want the area right here.
We don't want to bother drawing in the 1 plus e to the t.
What's that?
We don't want to draw the 1 plus e to the t, or we just don't care about it.
No, this is it. It is included in here.
Oh, okay.
This is dictating how fast the x-coordinate is moving.
Okay.
And this is what your y-coordinate's doing. All right, so what is the formula we're going to use to find the area there? Dun, dun, dun.
Integration from
I think your professor gave you a handout that had these notes.
very
Integral from alpha to beta, I'll let you catch up here, g of t, f prime t, dt. And that's it right there. This should be 9-2.
Yes.
See it there?
Yes.
So we need to know, let's start with the alpha and the beta. Do we have our time restriction here? What's our time restriction? Alpha and beta is the restriction on time. The time that would move me from here to here.
0 to 1.
0 to 1. So I know this integral is going to go from 0 to 1. And then it's going to be g of t. What is g of t?
It's going to be the
t minus t squared?
Yeah, that's your y function. That's this one right here. So t minus t squared. And then what is f prime of t?
the derivative of 1 plus et. So
Which
it's
is
e to the t.
e to the t. Uh-oh.
Wait, where's the t? E to the t.
We don't see the t.
No.
That's right.
Yeah.
Because we're going to transform the t.
Variable. Yeah.
So
Mm-hmm.
now we're going to have to multiply that through.
You want to multiply that through?
Well,
Yeah, it's fine with me.
hold on.
So would it be better to
Yeah.
IDP it?
Yeah, actually, yeah. Let's go ahead and multiply that through, and then you're probably going to do like integration by parts
Yeah.
and split into 2 integrals.
Yep. You can do that. So I'm going to break this up into 2 integrals after distributing the e to the t through both of these. And so distribute the e to the t through, break it into 2 integrals. Minus sign was right here. And then integration by parts on both of these. So let me do that first integral over here. Just what is the integral of t e to the t dt? Table, u dv, u is t, e to the t dt, v is e to the t, du is dt. Ultraviolet, t e to the t, minus integral voodoo e to the t dt.
We already know what that is.
We already know what that is. So that is, this right here, this integral becomes
T e to the t.
t e to the t minus e to the t,
Let's just worry about the constant.
0 to 1. My goodness, I cannot believe this. Hello.
Attention. You've been
It's been like this all, like yesterday, just almost nonstop.
FYI, Texas is one of the few states that has a harassment law.
Yeah.
If they call you a certain amount of times in a month and you can show that on your bill, there is no trial. It's an automatic bench summary of like $25,000.
Maybe they can keep calling me then.
The best I've heard is a guy in England, he paid like a couple $100 to have his phone number registered as an official 900 number.
So every time they call him, he bills them 10 cents a minute.
He just chats him up. He's already made like $10,000 doing that.
That's pretty smart.
In England. I don't know, but here, you register, yeah, if you pay money, officially.
All right, so look, I got this first one taken care of, right?
Yes, sir.
This first one is good. We'll have to evaluate that. This other one, it's going to change to t squared, and we're going to have to integration by parts twice. Right, so 2t, but I'll cheat a little bit. 2d dt right there. And then we'll just replace it. This will go right in because this is not basic U sub.
Yeah, sorry.
So ultraviolet will be t squared e to the t minus, now your integral voodoo, and this is where I'll pop the 2 out. So 2 integrals of what? T dt times e to the t, right? So t
Yes.
e to the t dt. I would normally need to do integration by parts again, but I just did this integral.
Yeah.
And I know what the answer to that is. Understand?
Yeah.
So this is going to become minus, now, it's t squared e to the t minus 2 times
The integral.
this answer right here. T e to the t minus t, right? All of that evaluated from 0 to 1. See how I did that? Kind of shortcutted it there a little bit. Let's plug in 1 and see what we get, and then subtract what we get when we plug in 0. So when I plug in 1 here, I get E minus E.
So that's 0.
And I'm going to kind of keep these separated. That's what I get when I plug in 1. When I plug in 0, I get 0 minus e to the 0 is 1. So negative 1. So minus, be careful here, minus negative 1. That's really going to be plus 1. Okay, that right there was this one right here. That's this. Now I need to do this one. So make sure you put that minus right here. Minus, bracket, let's plug in. First plug in 1, you get 1e. I'll put this one in parentheses. Minus 2, and then what happens when I plug 1 into this? I get
1e minus 1.
1e. Oh, wait a minute. Did I write that down wrong?
Yeah.
Wasn't this supposed to be e to the t,
Yes.
right? It was supposed to be this right here, right?
Yeah.
I just wrote it down wrong. I
I
apologize.
wrote it e to the t.
Yeah, it's supposed to be e to the t. So we already knew when we plugged in 1 into this, we got 0, didn't we?
Yeah.
So that's 0. Okay, and now minus, now let's plug in 0. So when we plug 0 into here, we get 0 minus 2 times, what happens when we plug 0 into this?
1.
Negative 1, right? So negative 1.
So it turns out to be 1.
Lots of parentheses and stuff here.
There's not too much to clean up.
Hey, your last test taught me the valuable lesson of those things.
Yeah. All right, we have here 1. Okay, minus. Okay, let's try and figure out what this is. This is gone. So this was E. This was positive 2, but then minus, so minus 2, right? But all of this being subtracted.
So negative e.
So negative e plus 2. So it's going to
You
be
can
negative
combine.
e plus 3.
Yep, 3 minus e.
Oh.
Yay, that's it. Okay, that's the area.
Crazy.
3 minus e.
Unit squared.
All right.
Whatever.
What number are we on?
29, we just finished.
37 now?
I think so.
Yes.
I only have about 20 more minutes, guys. 37.
If you're down, I think you could probably do 37.
39.
Or is it 39?
Mm-hmm.
My bad. We did 39. The 9.4 stuff doesn't seem so bad as long as you don't
Yeah.
crank it to the moon.
Well, I'll do them. I just won't be able to do them right now.
Oh, that's fine.
I might do them when I come back later.
Sure, we'll keep an eye out on
Okay, so look, let's do 37. Let's do 37. I want to just finish this section up. 37, they give us,
Find the exact length of the curve. The arc length.
okay, x is 1, what is it?
1 plus 3t squared,
Uh-huh.
and y is 4 plus 2t cubed, and our boundaries are 0 is less than equal to t,
Uh-huh.
which is less than equal to 1. 0, keep it around the unit.
Okay. T is an element of 0, 1. They want arc length,
Yes.
right? So the formula for arc length is
Integral from a to b.
alpha beta?
Yes.
Alpha
Or
beta.
AB, however you want.
Did I use AB on there?
AB.
I did?
Mm-hmm. AB. You can use alpha beta, it doesn't matter.
Well, no, because I think I should have put alpha beta. I should have put alpha beta here. Oh, no. You're looking at, recall, this is the old formula.
Oh, okay.
This is the new one right there.
Oh,
Yeah.
okay, sorry. Alpha beta.
Alpha beta, square root, and now it's going to be the derivative of y with respect to t, or derivative of x with respect to t squared. So derivative of this squared, derivative of that is 6t, right?
Yes.
6t and then squared. 36 t squared plus the derivative of y with respect to t squared. And that's derivative of this is 6t squared, and when you square that you get 36t to the 4th, right? Because when you're squaring it, dt. Oh yeah, this is going to work out real nice. Oh, what was my alpha beta? 0, 1?
0.
Okay. This is integral 0, 1. 6t root 1 plus t squared dt. So here, what did I do?
You just took 36t.
They each have a 36t squared in them, right? So I pull that out, 36t squared, but then take the square root of it, and it comes to 6t on the outside.
Gotcha.
What's inside is what was left when I pulled the 36t squared out, which would be a 1 and then a t squared. 1 plus t squared. And this right here,
Is, I think, a formula.
don't need one.
Yeah.
Go back to old days, the good old days.
Do them, you can do them separately almost. So you just get t plus or minus 1. Because they should factor, right? Yeah. T is t squared. Yeah. Because then plus t minus t.
It's
One
arc
plus
sign. No, that's not arc sign.
Arc tangent.
Yeah.
You're working too hard.
Probably.
Split apart.
Taught it at the very end of Cal 1 with integration.
The substitution?
Okay.
Oh, you substitute that whole thing.
What?
Like, your substitution is 1 plus t squared, and then you're gonna, when you get the derivative of what's inside that, you're gonna find that you're gonna just have to factor out, there's your t dt.
Okay, so we noticed that if you look at the inside here, 1 plus t squared, let that be u. The derivative of that is 2t. You have 6t. You're off by a constant. It's okay. So I'm gonna just work on that integral by itself without the definite part, without the 0 to 1. If I have the integral 6t, let's take the 6 out. 6t root 1 plus t squared dt. And I make this substitution, then it's going to be 6 integral the t dt right there. That's 1/2 du, right? I'll just throw that to the back. And then what's still here is root u.
And so that's just another thing that 3 over there.
Yeah, and then that's just going to become 3 integral u to the half du. And that's power rule, so add 1 to that, you get 3 halves, but scale 2/3. Plus some constant, but it's not going to matter because this is a definite integral.
It just ends up being 2u.
So 2u, what was u?
The
1 plus t squared to the 3 halves, right? Okay, so now come back over here. I know that this is 2 times 1 plus t squared to the 3 halves, evaluated from 0 to 1. When I plug in 1, I'm going to get 1 squared plus 1. That's 2. So it's going to be the 2 that was out front, and then it's going to be 2 to the 3 halves, minus, now plug in 0. And when you plug in 0, you just get 1. 1 to anything is just 1, then times 2. So 2, like that. And do we want to leave it like that?
I mean, it's a number.
We can. You can.
Actually, you get 4 root 2 minus 2.
Yeah. We can do so many different things. I'm just going to leave it like this. You could get it as a decimal. I don't care. That is the exact answer, and it's good enough.
On the test, you're good with the exact answer there?
Yeah.
Or would you rather have the approximate?
No, exact's fine.
Cool.
So
Yeah.
for me, you'd be like, no, I wanted you to
Sorry.
look at all 3 and stuff.
Sorry, Jacob.
39's next, right? X is
You ready to?
t, I got it. T sine t, t cosine t? Or the other way around? T,
It's t sine t for
Yeah.
x, and then y is t cosine t.
right, this one I might need to just take my time a little bit more. This previous one, we did the derivatives in our head and plugged them in there, but I might have to
And
work those derivatives out a little bit more. Actually, no.
0 to 1.
0 to 1? 0 to 1. All right, let's take a look at the derivative of x with respect to t, because then we're going to have to square it, right, to put it in there. That's a product rule, right? So sine t plus t cosine t. Now square it means multiply it times itself.
Pascal's triangle. So sine squared t
Yeah, so this is going to be sine squared t
2
plus,
2t cosine t.
yeah, 2t cosine t sine t,
Oh my gosh.
right? Because we're doing this times this, that was sine squared. This times this gave us a t cosine t sine t, but then the inside one gave us another t cosine t sine t. And then the last one will give us plus t squared cosine squared t.
Pascal's triangle. Got it.
Now, what? Let's just leave it. Okay, now what's dx, dy dt? So this is a separate thing here. Should be very similar, but with some minuses in there, right? So we first have cosine t, but then it's going to be minus t sine t. So that's our product rule. Let's square it. Let me go ahead and square it right here, just to save myself from writing it again. And when I square that, I should get cosine squared t minus 2t cosine t sine t plus t squared sine squared t. I didn't actually show the foiling out, I just did it. You can verify yourself.
Well, I know Pascal's triangles, so
Yeah.
that helps. I think that's like the best trick you ever told me in 1414.
Yeah.
It helps. Which is pretty interesting.
We're supposed to take both of these, right?
Yeah.
Add them together underneath here. Add them. What happens if you add those two? If you add this and this together, there are some good things that happen there.
The middle cancels out.
The middles cancel. I agree. Hold on, I need to do something real quick. And yeah, we're going to have an identity in there too. So we're going to have sine squared t plus cosine squared t, which is 1, plus, let's see, this right here and this right here cancel.
And then 2.
These two together, right?
Is not an identity?
Well, they both have t squared in them, right? So you can factor that out. So you would have t squared cosine squared t plus t squared sine squared t. Factor out t squared, and what was left would turn into a 1. So this is just going to be t squared dt. That's it. This is all that's there. And now integration of that.
Again, simple substitution.
No, there's not a t on the outside this
Oh,
time.
that's right.
So this one you would do with trig sub, but this is a formula. It's just the root by itself. I think it's right on the left-hand side, the first one there. Yeah. Yep, that one right there. So using formula number 21,
1 squared plus b squared.
what we have here is a is 1, right?
Yep.
So can I borrow it real quick? I just want to make sure I get it right here. So we have u, which for us is t. So t over 2, so 1/2 t root of 1 plus t squared is formula 21. And then plus a squared, a is 1, so 1 squared over 2, which is that. And then natural log of t plus square root of 1 plus t squared. Yay. All right, 0 to 1. That should be it. Plug in 1, and we get 1/2 square root of 2 plus 1/2 natural log of 1 plus root 2. So that's just replacing all our t's with 1s. And then minus plug in 0. And when we plug in 0, I believe everything goes away. Because 0 here is going to kill off this entire piece.
And then 0 in there.
0 here is going to give me a 1, and then plus 0, but that's in a log, and
That's
log of
the
1 is 0.
0.
So that's it right there. That's the exact answer.
Looks lovely.
I love that.
All right, that was number 39.
Yeah.
Was that it?
I think you're
Okay.
Out of time too, sir.
Yeah, it's perfect. How long is this video? Right under an hour.